Today's lesson is on solution concentration. So this is if you are going to take some kind of a solute and dissolve it into a solvent. This is going to tell you just how concentrated those particular solutions are going to end up. So that's what this section is on. So expressing concentration. Concentration is a measure of how much solute is dissolved in a specific amount of solvent. So the solute here being substance being dissolved, and the solvent being substance doing the dissolving. Okay, we've seen those terms before. And things can be concentrated or diluted. So for instance here with this tea in the coffee pot, over here on the left hand side, okay, we would just by looking at this, you'd say, well, there are more tea bags in here, and this is a darker colored tea. This is going to be more concentrated than the one over here on the right. This one's going to have more flavor to it. This one will be diluted. It'll have more water to it. So that's basically what we're doing here, but we are quantifying it. We are giving it a number, and we are giving it a unit. There are various ways to express concentration. Percent by mass, percent by volume, molarity, molality, mole fraction. We aren't going to see percent by mass very often. Percent by volume, oftentimes you'll see this as, if you go to the grocery store, it's represented as ABV on alcoholic beverages, which is alcohol by volume. So it's just telling you that it's the volume of the solute divided by the volume of the solution times 100. And that in this situation here, these are both volumes, so they're both liquids. Our most common way of expressing concentration is going to be molarity, which is moles of solute per liters of solution. And so you should by now at this point be good on how to find the moles of something, right? Grams divided by molar mass. And liters, it's important here that we pay attention to that. It does need to be a liter. It can't be milliliters or anything else. It's got to be in liters in order for molarity to work. So just keep that in mind. Okay, so molarity is the number of moles of solute dissolved per liter of solution. So it's a way of quantifying how concentrated something is. It's also called molar concentration. The abbreviation for this is an italicized capital M. So do not confuse this with molar mass, which has the symbol, change my color here, which has the symbol a cursive capital M. Okay, so don't confuse it with that. This is usually an italicized capital M. Is an abbreviation for it. So you'll see that. You'll also see it written as moles over liters, moles divided by liters. Okay, so sometimes it will be written like this, but most often you'll see it abbreviated like that. And obviously the bigger the number, the more concentrated something is. Okay, so concentrations are written as, and you'll see these brackets. The brackets mean concentration. So when you see these written, okay, think in your head the concentration of whatever's in between the bracket there. Okay, that's what that means. That's how you would read that verbally. Okay, they're written in brackets. So down below there, right underneath it, the CaCl2, calcium chloride, you'd read that as the concentration of calcium chloride is equal to 0.150, and you would say here molar. 0.150 molar. Or you could say moles per liter, but that's how that is read. Okay, so the equation for this, down below, molarity equals the moles of solute divided by liters of solution. That is your equation for molarity. It's a very simple equation. It's one thing divided by the other. You just have to make sure you know how to calculate moles, okay, and make sure you know how to put things into liters if given them in milliliters. So, example problem 1, you want to prepare 2-liter aqueous solution of 1.25 molar. This is copper 2 sulfate pentahydrate. How much do you need in grams to measure out to make the solution? So, the first thing we want to do, if we're trying to find an answer in grams, so this is kind of a problem taking us back to what we've been talking about with stoichiometry. we need to first get the number of moles. So what I want to do is rearrange this equation here. I want to rearrange that equation. I'm given a molarity and I'm given a volume, so I want to solve for here moles of solute. That should be the first thing I want to solve for. So if that's the case, I need to multiply both sides. Multiply both sides by liters. So I'm going to end up getting moles are equal to your molarity times your volume. Okay, volume being in liters here. Molarity times volume. So the number of moles this thing's going to have, okay, grabbing a calculator here, we're going to take the 1.25 molar times the 2 liters. Oops, come on, what's going on here? Let's see if I can get this calculator to work. Here we go. 1.25 molars times 2 liters. Okay, if we're writing that out, and the number of moles here is going to equal, this is easy enough, 2.5 and then 0 with 3 significant figures, moles of CuSO4.5H2O. Okay, but if this problem wanted an answer in grams, all right, I need to make use of the molar mass of this thing, CuSO4.5H2O. So to find the mass, it's just going to be moles times molar mass. So we're going to take the 2.50 moles times its molar mass up there, 249.69 grams per mole. That's coming off the periodic table and with 5 waters. So 2.5 times 249.69. Okay, we get 624 grams. So that's how much you'd have to put into the water to make it have that kind of concentration. So you'd have to weigh that out on the scale, and then you'd end up with a 1.25 molar solution if you put that in 2 liters of water. Another example here. 2.56 grams of AgNO3 is dissolved into 1.100 liters of water. What is the molarity of the solution? So once again, your equation for molarity is moles divided by volume in liters. I don't have moles here, but I do have grams, and I can very easily find the moles by taking the 2.56 grams of AgNO3, dividing by its molar mass, okay, which is 169.88 grams per mole. So that's going to give us 0.0151 moles. Alright, and if I'm going to put it into 0.100 liters, my equation over here, the molarity is going to be 0.0151 moles divided by 0.100 liters. And we're just going to be moving decimal places here when we do this. We're going to end up with 0.151 molar AgNO3. Okay, that's how concentrated it is, 0.151 molar. Another example here, how much H2O is needed to create a 0.250 molar solution with 42.65 grams of, and this is calcium oxide. Okay, so this time we're trying to solve for a volume. All right, my equation is, molarity is moles over volume, okay, which is in liters. I can very quickly, once again, get the number of moles, taking the 42.65 grams, dividing by the molar mass up at the top there, calculated ahead of time. So 42.65 divided by 56.08. Okay, and we end up with 0.7605 moles of calcium oxide. And if I'm solving for the volume now, I'm going to bring volume up to this side and bring the molarity over to that side. I end up with volume equals moles divided by molarity. So the volume here is going to be 0.7605 moles. CaO divided by the molarity given is 0.250 molar. Okay, so how much water do you need for that? We get with three significant figures 3.04 liters. So you need 3.04 liters of water to make that kind of a solution, 0.250 molar, given 42.65 grams of that substance. Okay, and then we have one more thing here on molarity, which is dilution. This is actually a very helpful equation and something you might always want to remember. So, for instance, here's our problem. Concentrated hydrochloric acid, HCl, can be purchased at 12.0 molar. However, the solution is too concentrated for lab work. It must be diluted. Basically, it just would start burning through your skin if you got it on you, so we always have to dilute it down. All right, suppose a 0.250 liter aqueous solution of 12.0 molar HCl needs to be diluted to 1.25 molar. So you're going to add water to it to take it from 12 molar down to 1.25 molar. How much water do you have to add? Okay, and so why would we do this in the first place? Why do they sell it like this? Well, they sell it very concentrated because then they don't have to ship as much in terms of the size of it. Something that's 12 molar can always be diluted whenever it arrives. So they sell it very, very concentrated, and we dilute it down to whatever concentration we want it to. So we actually do this quite a bit when it comes to acids. The equation for dilution is M1V1 equals M2V2. Okay, that is molarity of your first thing times the volume of the first thing must equal the molarity of the second thing times the volume of the second thing. Okay, that is your dilution equation. So what does it look like when we are going to solve it? Well, just a quick little thing on this. The volume does not have to be in liters, but it must be consistent. Okay, so if you're given milliliters, you have to stay in milliliters. If you're given liters, you have to stay in liters. So here's our problem here. We want to find, so the question asks how much water is added, which is a little bit different than another possible question. How much water is added? Well, my equation is M1V1 equals M2V2. I know the molarity and volume of the first thing. Okay, I don't know the volume of the second thing. So if I rearrange this to solve for V2, I have V2 equals M1V1 over M2. Okay, and then we can just plug in our values. The first molarity, 12.0 molar. First volume, 0.250 liters. Okay, divided by, we've got 1.25 molar is the second molarity. Okay, so 12.0 times 0.25 divided by 1.25. Okay, the second volume is equal to, with three significant figures, 2.40 liters. 2.40 liters. That is the final volume. Okay, that's what the final volume is. If the question asked, what is the final volume? You'd be done right there. Right? You've calculated what the final volume of the water is, which would be 2.40 liters. This question asked, how much water did you add? Well, you didn't start with 0. You started with 0.250 liters. So all you have to do to figure out how much you added, well, take what you ended with. You ended with 2.40 liters. You started with 0.250 liters. Meaning that we added 2.15 liters of water. So you'd have to actually add 2.15 liters of water to make the final volume 2.40 liters. Okay, so if it asks how much water is added, that is a different question than what is the final volume. All right, so hopefully you understand the difference there. So if you've got some kind of a solution, you're adding water to it, Okay, if that's the question, you have to answer it that way. All right, that's it.